All right, hello everyone. Welcome back. We're talking today about linear relations, how we can graph them, and why are they called linear relations? Well, I've created here a table of values. You can see the values of the x and the y for this relation. The x is going up by 1, 0, 1, 2, 3, and these are the y values, the corresponding y values. And I've used this program Desmos to plot them. So you can see those points there. Each one of those represents one of the numbers, or one of the pair of numbers in my table of values. So 0 and -1, that's this point here. 0 on the x, -1 on the y. And you have 1 and 0, that goes here. 1, 0. And then 2 and 4, that's 2 and 4. Then 3 and 5. 3 and 5. All right, so this is a relation. But is it a linear relation? Well, let's take a look at those numbers. We go up by 1 for the x, and then for the y, we go from -1 to 0, so we add 1. Then from 0 to 4, we add 4. And then from 4 to 5, we add 1. So no, this is not a linear relation. We didn't go up by the same amount each time. We went up by 1, and then we went up by 4, and then we went up by 1. Not a linear relation. The change is not constant. And if you look at the graph, the points are also a little bit more scattered. They're not creating a line, a straight line. It's more of a curve. So because it's not a straight line, it's not linear. You notice the word linear, the first 4 letters, L-I-N-E, are line. A linear relation, if you graph it, is going to make a line. So let's make this into a linear relation. Now, how do we do that? Well, let's change those values so that they increase by a constant amount. Let's make that constant amount 2. So let's start with the same point, 0, -1. And then the second point will make it increase by 2. So -1 plus 2. -1 plus 2 is 1. And then 1 plus 2, that's 3. And then 3 plus 2 is 5. So we won't change that one. So now these are the new values here, the new points. And they are now on a line. Now let's see if we can figure out the equation for this using what we learned. So we said that every time we increase by 1, we increase this by 2. So that is the rate of change. So y equals, this is the equation for our relation, y equals 2 times x. Now you notice this is the graph. This red line is the graph of y equals 2x. Every value of x, including little points between 0 and 1, fractions and so on, are graphed here. And when you put all those points together, you create this line. But you notice this line does not go through these points. Well, that's because we're not finished, are we? We said the first step is to check how much each value of y increases every time you add 1 to x. But then we said, okay, well, let's check. What happens when we have x is equal to 0? Let's substitute that in here. Y equals 2 times 0, that's 0. That's not equal to -1. Well, how do we get from 0 to -1? Well, we subtract 1. So y is equal to 2x minus 1. Take a different number. Let's say x is equal to 3. If x is equal to 3, 2 times 3 is 6. You want to get from 6 to 5, you subtract 1. So again, -1. It would work with any pair of numbers that you pick here. So y equals 2x minus 1. And now our line does go through all of our points. So y is equal to 2x minus 1 is the equation of this table of values. And it's a line, and that's why we call these relations linear relations.